Welcome, algebra students, to the start of Chapter 7, which is talking about exponents. Today we're going to be talking about zero and negative exponents. So the origin of all exponents, let's start with the zero, okay? Well, first we need to understand what an exponent does. So if we have 4 to the first power, what that 1 means is we're going to multiply 4 times itself one time. Let's use the color purple. So 4 times itself one time is what that 1 means. So that equals 4. Okay. Now, what does this 2 mean? This power of 2 means we're going to multiply 4 times itself twice. So that's 4 times 4. Now, 3, of course, the pattern continues. We have 4 times 4 times 4. So what happens if we have 4 to the 0 power? 4 times itself 0 times. Well, that's kind of hard to understand because that's not the same thing as 4 times 0, which would be 0. Most people put this as 0, but that is not correct. So let's take a look. Well, in order to understand what 4 to the 0 power means, we first have to change all of these to be 4 times 4 times 4 times 1. Does that change the value of the expression? It doesn't. When you multiply by 1, it doesn't change the value. So we multiply this by 1. 4 times 4 times 1 is the same thing as 4 times 4. Multiply by 1. I hope you guys can see sort of a pyramid shape taking form with one less 4 as we go up the pyramid. So lastly, if we start with 3/4, then we have 2, and then we have 1. We take away 1/4, and we're left with just 1. Okay, so that is our rule. So if we look at a to the 0 power, that is going to equal 1. So any value raised to the 0 power equals 1. Let's do some examples. So over here we have -3 to the 0 power, and that equals 1. 2.73 raised to the 0 power, that equals 1. The square root of 173 to the 0 power equals 1. So as you can see, anytime you see something raised to the 0 power, it is always equal to 1, okay? It's not equal to 0. That's a common misconception, is 4 to the 0 power equals 0. That's not true because 4 times 0 equals 0. So don't think that. Let's cross that one off. Okay, so if you need to pause and digest that information, now is a good time. Otherwise, we're going to continue with negative exponents. Now, negative exponents are a little tricky. So most of the time when we have negative exponents, okay, we have 7 to the -1, and most people will put that it's -7. That is not true. Why? Well, if we wanted -7, we would write it like this: -7 to the first power. Okay, what that means is we would do exponents first, order of operations. That's 7, and then we would add the negative sign, -7. Okay, same thing with 7 to the -2, 7 to the -3. That's not what you do, okay? So what does it mean? Well, it means that it is 1 over 7 to the first power. Anytime you have a negative exponent, it gets rewritten as a fraction, okay? Where to make it positive, so this 1 went from a -1 to +1. In order to make it positive, we had to put it in the denominator with 1 in the numerator, okay? So what happens if we have 7 to the -2? Well, in order to make it positive, okay, so if we wanted a positive exponent, we have to put it under 1, okay? So the -2 became +2, but it had to be over 1. A common mistake that I see is people rewrite 7 to the -2 like this. Okay, you can't just change it. If you're going to change this -2 to be under 1, then something needs to change with the exponent. You just can't keep the same exponent. This is changing the value, so this is bad. You don't want to do this, okay? But that's pretty common. So now we have 7 to the -3. I hope you guys are seeing the pattern. It's 1 over 7 to the 3rd power, okay? Let's do some examples. And again, this is probably one of the toughest part of exponents is the negative exponent. So here we have -5 to the -2nd power. So the first thing I'm going to do is I'm going to rewrite this with a positive 2. Negative 5 to the positive second power. Now if I do that, something needs to change. I need to put it under 1. Okay, and I could further simplify this. 1 over what's negative 5 times negative 5. Negative 5 times itself twice is 25. Okay, now I have 2 to the negative third. So I have a negative power here. I want to rewrite it as a positive exponent. So I'm going to rewrite it as 2 to the positive 3 power, but I need to put it under 1. Now I can simplify that. That's the same thing as 1 over 2 times 2 times 2. It equals 1 over 8. Finally, a little bit more of a tricky example. We have 2x to the negative first power. So how do we do this? Well, what we're going to do is we're going to make the exponent positive like this and just put it under 1. So anything to the first power is just itself. So this equals 1 over 2x. And that's our answer. Let's move on to some tougher examples. We're almost done. We only have about 9 examples left, and then we're done, okay? So anytime you see a negative exponent, you're going to want to rewrite it to be positive, okay? So these numbers are fine there, but it's only the negative 2 that needs changing. So what we're going to do is we are going to write 5a cubed, and then we rewrite b to the negative 2 to have a positive exponent. Well, in order to do that, we have to put it under 1. Now we have 5a cubed times 1 over b squared, which is 5a cubed. If you want, put this over 1, so you can see you're multiplying 2 fractions, over b squared. And that is our answer. Let me make it a little bit bigger. Okay, one way I like to think of this is anytime you have a negative exponent, so you have b to the negative second, this is simply going to go to the denominator. Okay, so you're going to have an invisible fraction bar, and you're going to add it there. And then this goes to the denominator to become positive, okay, as it is demonstrated here. So it went from the numerator as negative to the denominator as positive, okay? Okay, here's something tricky. Now we have 1 over x to the negative fifth. I thought that if you have a negative exponent, it automatically goes to the denominator. Well, of course, in math, we can have compound fractions, and that's what this technically is. This is technically 1 over x to the fifth. An easier way to think of this is you change this sign into divide. So this becomes 1 divided by 1 over x to the fifth power, okay? Because when you make x to the negative 5 positive, it goes 1 over x to the fifth. Now let's use our keep, change, flip rules. Here, let me use purple. We keep, change, flip. So we're going to keep the 1. We're going to change the divide into multiplication, and we're going to flip the last term to be its reciprocal. Dividing is the same thing as multiplying by the reciprocal. So this becomes 1 times x to the fifth over 1. That equals 1x to the fifth over 1, or just x to the fifth. So what happens? The way to think of it, okay, over here we had b to the negative 2, and it was in the numerator, it goes to the denominator. Here we had x to the negative fifth, it was in the denominator, it went to the numerator. As you can see here, it goes to the numerator. So anytime you have a negative exponent, think about it flipping, okay? So if we have x to the negative 1 over 1, this changes to go into the denominator, so we have 1 over x to the 1. And if we had 1 over x to the negative 1, again, this changes to become x to the 1 over 1. Okay, so anytime you have a negative exponent, think about it, it flips to the other side of the fraction. Okay, let's do a couple more. So we have 2 over n to the negative 3. This could be rewritten as 2 divided by n to the negative 3, or 2 divided by 1 over n to the positive 3, keep change flip, 2 times n cubed over 1 equals 2n cubed. Okay, and I'm going kind of fast, but make sure if you want, go ahead and rewatch these and hear the explanation another time. What I like to do is I'm going to show you my shortcut real quick. Anytime I see a negative exponent, I know it's going to go to the other side. So I'm going to go ahead and rewrite this over here. I think it's going to be 3y. That stays because there's no exponents for the 3. There's no exponents for the y, so they need to stay where they are. The z cubed, same thing. That's not a negative exponent. It needs to stay where it is. So I'm going to write it over z cubed. The only thing that needs to change is this x to negative 4th. I'm going to rewrite it as positive in the denominator. So it's going to be like this. Let's verify that. So I can rewrite this as 3y over z cubed times x to the negative 4th. That's the same thing as 3y over z cubed times 1 over x to the 4th. And then we get the result that you see to the right. Okay, so that's just another way that I like to think of negative exponents. Okay, we have just a couple more examples, so I'm going to do these quickly just so we have enough time. So if we have evaluating for when we have known variables for variables, we're just going to plug them in. So we have 3, and then we have 2 cubed, and then we're going to multiply by negative 3 to the negative second power. Let's simplify this. So we have 3 times 2 cubed is 8. 2 times 2 times 2. Okay, just to show you. Times, now let's rewrite this with a positive exponent here, negative 2. We're going to rewrite this as, let me use orange, 1 over negative 3 squared. I'm going to simplify again using red. So we have 3 times 8 is 24, times 1 over negative 3 squared. Negative 3 times negative 3 is 9. So this equals 24 times 1, 24. 1 over 1 times 9, 9. 24 over 9. Moving on to the last couple examples, we have n to the negative 4. I'm going to change this to 1 over n to the 4th. Times w to the 0. Anything to the 0 power is 1. So this becomes 1 over n to the 4th times 1. 1 over n to the 4th. Final answer. Anytime you see a negative exponent, think that it's going to go to the denominator. So I like to think of it as like this. 1 over n to the 1st, w to the 2nd, or just 1 over n w to the 2nd. N to the 0 is just 1. W to the 6, that's that answer. And then anything that's a negative exponent is going to go to the other side. So we have 1 times w to the 1st over n, which is just w over n. I went fast at the end, but again, try to think of the examples. Change to division if you need to with the compound fractions. Keep change flip. Hope you guys found this helpful, and I'll see you next time when we talk about more multiplication powers with like base.